We want to find the domain of the given log functions, and then state the domain using inequalities and interval notation. Looking at our first function, we have y equals log base 2 of the quantity 2x minus 4. The quantity 2x minus 4 is the number part of the log that's obtained by raising 2 to the power of y. Remember, in exponential form, 2 is the base, y is the exponent, and the number would be the quantity 2x minus 4. So if we think about all the possible values we get when raising 2 to a power, well, the result is always going to be greater than 0. And that's the reason why, to find the domain, we have to solve the inequality 2x minus 4 is greater than 0. So the number part of a logarithm is always going to be greater than 0. So now we'll add 4 to both sides. That would give us 2x is greater than 4. Divide both sides by 2. So we have x is greater than 2. So our domain would be x greater than 2 using inequalities. If we want to express this using interval notation, it might be helpful to sketch a graph. So if this is 2, we'd have an open point on 2, arrow to the right, approaching positive infinity. Therefore, using interval notation, we have the interval from 2 to infinity, and it's open on 2 because it does not include 2. Okay, looking at our second example, notice how there's no base listed on this log, therefore we know it's common log, or log base 10. And again, if we focus on the number part of the log, the quantity x squared minus 3x would be obtained by raising 10 to the power of y, which would always be greater than 0. Therefore, to find the domain of this function, we need to solve the inequality x squared minus 3x greater than 0. The solutions to this will be the domain of our function. To solve a quadratic inequality, we first find the solutions as if it was an equation. So this does factor, so we want to first solve the equation x times the quantity x minus 3 is equal to 0. Well, this would be 0 when x equals 0, or when x equals 3. So these are the values of x where it would be equal to 0. We want to find the x values where it's greater than 0. So what we'll do now is sketch a number line, plot these two values as open points because of the inequality symbol, and then test x values in each of these three intervals to see which satisfy the original inequality. So let's test x equals -1, let's say 1, and let's say 4. If we let x equal 4, we'd have 4 squared is 16 minus 12, that's 4, which is greater than 0. So this interval is true. Let's go ahead and graph it. Approaching positive infinity. When x is 1, we'd have 1 minus 3, that's -2, which is not greater than 0, so this is false. And then when x is -1, we'd have +1 minus 3 times -1, that becomes 1 plus 3, which is 4, which is greater than 0, so this is true. So this interval is also part of the domain, approaching negative infinity. So the domain, using inequalities, would be x is less than 0, or x is greater than 3. Or using interval notation, we'd have the interval from negative infinity to 0, union 3 to infinity. Again, it does not include these endpoints, therefore we have open intervals on 3 and 0. Okay, thank you for watching.